In this video, we're going to be picking up from where we left off from the previous video, and I'm going to go ahead and preface and say that, this entire project and all the videos related to this project are all for educational purposes. It's for learning, so none of the files are going to be publicly shared. The server is not going to be publicly shared. Nothing is going to be publicly shared. I'm just recording myself as I'm doing this for, if anybody else wants to learn, and just so that I can go back and see what I've done. Maybe I made mistakes. I can learn from it, and it's also nice as a point of reference on the things that I know how to do. And so in the last video, what we were doing is we're still in the planning phase of Agile methodology. And if you guys remember, I just want to remind people that there's the Agile methodology, and then there's methodologies in the Agile methodology, like Scrum, Kanban, Scrumban, which is a mix of the other two I just mentioned. And then you have sprints and stuff like that. We're definitely going to be using Kanban in here when I set up my Jira board. But right now, yeah, we're in the planning phase. We're in the third step of the requirements gathering, which is the software specification requirements. I think it's what's called, right? Software requirements specification, the first two that we did in the previous videos was step 1 was the business requirements document. Step 2 is the user specification requirements. And you can create 3 separate documents for each. So business requirements document, user specifications, user requirements specification, and then software requirements specification. But you can also combine the business requirements document with the user requirements specification in one document instead of creating 2 separate ones, which is what I'm doing. And yeah, right now we're just in the planning phase. We're just like gathering requirements, like the technologies that we're going to use, and detailing, kind of how everything's going to be set up. In ways that anybody can understand, not just people in the domain of whatever job you're doing. Like if it's, for example, software development, you have technical jargon like API. Some normal person, like some person that doesn't work in the software development field, might not understand what API is. So that's kind of what these documents are for, is to gather what the client needs and what the users would want. So like you're creating a product with a client. The client is going to ask you for things that is going to tell you what they want. And they're going to have users. The clients are going to have users that might want something from the product, which is why the clients are asking us to create the product, because it's usually for users of the client. And so we gather the information and then we write it down, and we try to figure out what we're going to need in terms of software if you're in the software development field. What kind of APIs, what kind of platforms you're going to use, libraries and this and that, what kind of programming languages, what kind of tools, external tools you could use, version tracking tools, stuff like that. And then that's pretty much it. So you're able to, also determine how much money you need to spend, what you need, because some things require money, subscriptions and stuff like that. And then, so how much time and money, right? which is very important because you need to be able to know if by the end of the project you're going to be making money, not losing money, right? And not losing money in time. Because the client is going to pay you a certain amount of money, you have a certain amount of time. If you take too long, then you're going to lose money. And if you spend too much on tools, then you're going to lose money, right? Anyways, I do want to say that like I said, I've been doing these things. The user requirement specification that I did in the previous videos, I did it wrong in the sense that I was using ChatGPT examples. I didn't do that for the business requirements document, and I think it's crucial that we, as people, should think for ourselves. And so that's what I'm doing from now on is instead of using examples, because what I noticed was that ChatGPT was giving me all the answers. Even though there were examples, there were literally all the examples that I should have thought of myself. And the reason why I was looking at the examples is because I wasn't understanding, what subsection of the documents meant. So I went to go look at the examples to see what it meant. But when I looked at the examples, it gave me the answers. Anyways, so moving forward, and I want to preface again, the business requirements document, I thought of the stuff myself. I didn't use any examples. And the software requirements specifications, I've been thinking for myself. But the user requirement specification, I was using ChatGPT examples, and it wasn't good. So another thing I want to talk about, you can see here in the software requirements specification is, I think I did this section wrong, the specific requirements. I don't even know because I'm not trying to see the definitions because I'm trying to think for myself. As I keep doing these things, I'm going to learn how to do it properly, but the specific requirements, which is part of the software requirements specification. So what we need to know right away is that this entire document is about software requirements, the specifications, right, for the requirements of the software. So if we have that in mind as, the overall context, what does specific requirements mean? Well, in the previous videos, what I was doing was I was just like, saying like, okay, we need a website, we need a layout page, we need a header, we need a body, footer, admin control panel. Yes. And then but the specific goal of this part, I think, is more to explain the specific requirement for each of those things that we're going to need, right? And for example, the website, we're going to be using Angular server running, right? So people can connect, even though nobody's going to be connecting to my stuff. And then we're going to need, for let's say the layout page, we're going to need SASS, HTML, and TypeScript. SASS is just a form of CSS, an advanced form, same as TypeScript. If you guys know TypeScript gets compiled down to JavaScript. And JavaScript is a standard across pretty much all web browsers these days, and for a long time. It's kind of like the logic. It's kind of like the logic, like how you interact with things on a web page, I guess. I guess you could kind of say HTML. Again, HTML is a standard for every page across like all web browsers. HTML is kind of like the layout. Like it's kind of like, I would say, the layout of everything on the page. If you want to have a section here for this, a section there for that, a section here for this, a section there for that. And then you want those things to do something, that's where you have TypeScript. And then for SCSS, it's just to make things, to style things. The CSS actually, SCSS gets converted down to CSS. SCSS is yeah, it just makes things look nice, like the background color, for example, um, and the size of the boxes, and if it's going to even be a box, like if you want a box, that's what the style sheet is for. That's what we call them, CSS, SASS style sheet. If you want a box, you want a specific size, you want it to be a specific background color, you want it to be an outline, border outline, and you want the border outline to be a specific color. You do that with style sheets, and then HTML is kind of like placing those things on the page. And then if you want something to happen from those specific portions, then you would have TypeScript where it actually, it does something on the page. When you click something, for example, maybe, if I remember correctly. And then, for example, we come down, a lot of the stuff is all the same because we're on the website right now, the website part of the functional requirements. It's all CSS, HTML, and JavaScript. And then if you go to anti-cheat, then here we have Java, right? The anti-cheat is going to be running on the server, and the server is a Java server written in Java. And then auto shutdown for server maintenance, that's going to be using Java. The server itself is going to be shutting itself down. But before it shuts down, what's going to happen is it's going to run a batch script. And that's going to need Windows Batch. And then we're going to need MySQL to connect to the server's database, and Windows Batch to extract the tables as XLSX files. So I think that's what is meant by specific requirements under software requirement specification. It's just like for each of those things, what is the specific requirement that we need, like kind of tool, kind of API, what kind of language or whatever. I could be wrong though. I will be looking after I'm done all this stuff to see, where I went wrong. But for now, I'm just going to try to think for myself. And here, another example is, one second. RapidMiner, we need RapidMiner, obviously. So, yeah. The other thing I want to mention is, we could go over, I think I already went over this stuff. So let's just continue. From the previous video, I did change a lot of things. I had some portions of the webs, like my descriptions, in the wrong section, so I just moved them around. But like I said, this is more about what is required for each of these things to function. So for the most part, I think I just this section should just be like website, Angular, SASS, HTML, TypeScript, and then server, anti-cheat, Java, MySQL, RapidMiner. That's all. We could get rid of all this stuff, I think, because I already kind of did all this in the previous documents, which I think is what those are for, is to outline, all the pages and all the this and that, what is doing what. So yeah, again, I think I did this wrong, but it's fine. We can keep this for now. I have a lot more detail in this than the other documents, so I'll just keep it. But yeah. Next, we have, so that's the functional requirements, and then we have external interface requirements. So here it's like any external tools, I guess, that we're going to be requiring. For example, RapidMiner and Batch, Windows Batch. I'm not 100% sure. External interface requirements. Maybe this is more like external tools that aren't exactly part of the product itself. So for example, Jira, GitHub, Angular, they don't come with the product, right? Technically. I mean, I guess RapidMiner does come with the product, because how are you going to run the server, the web server, and the Angular project. So I think external interface requirements is more like Jira, GitHub, I'm going to use Jira for, but this is software requirements specification. Anyways, I don't know. This is what I'm guessing. Where was I? Right here. So Jira, Kanban board, here we're gonna have product backlog in progress, and completed. GitHub, I don't really know what to say about GitHub. Performance requirements. This, I do think I did it right. Website. We're going to need website web pages should load within 5 seconds minimum. Web pages should have minimal clutter in order for this to be achievable. Character loading. So the characters that load should load within a minimum of 10 seconds, so 5 characters loaded per page. So it's going to be like a page thing where it loads 5 characters. You click the next button, it loads the next 5 characters, kind of like cursor-based pagination. The anti-cheat for the entire automated process of extracting MySQL tables and predicting class label GDS using RapidMiner should take up to 30 minutes maximum. It should take up to 30 minutes. So what that means is that the server, so the computer that the server is running on, should have a fast CPU, because that will reduce or increase, reduce the time it takes for RapidMiner to predict the data using supervised learning. And the machine learning model, well, the model that I teach using machine learning, Christian methodology. So design constraints. I think I did this right as well. I guess we could fix this. I think we should fix this. It's just there's so much information here that I could use in the other documents. So that's why I might not change it. But design constraints, this, I think it's more like, based on what you're using, what are the limits, right? So, for example, the game server, the programming language that it's using is Java. It's object oriented, and it builds the source. It compiles everything in the JVM and uses a decent amount of server resources to uh, run the Java application, which is the server itself, I think. If I remember correctly, Java um, applications run in the Java virtual machine. Let me look that up real quick. Okay, yeah, so I was right. So with Java applications, they run in the JVM. So what that means is that our game server, at the very least, our game server is going to be very portable across many operating systems because, or at least many hardware, which the game server is running on. So whatever computer or slash server that you're running your game server on, um, because the Java applications are running in their own virtual environment with specific, you know, settings, I guess you could say. They are very portable across many, you know, devices that are using different hardware and maybe operating systems. Maybe I'm not sure about that, but at least hardware. And the problem with Java is, you know, is that's a good point. That's a good selling point for Java is that it's very portable, but the JVM is using a lot of resources because of that. So that's one issue. So if somebody has like a bad like a computer with little resources like memory and CPU, then Java might not be the best language because it's running the JVM for running the application in, you know, its own virtual environment, and the virtual environment allocates resources from the computer, like, you know, hardware resources like memory and CPU cores and threads or whatever. So um, that's probably the major downside of a programming languages that run in their own like virtual machine, virtual environment. I mean, um, and then we have the web server, which is using Angular, um, SCSS, HTML, TypeScript. They're pretty much standards across all web browsers. More importantly, all uh, popular web browsers. And that means that they're very easy to use across, you know, any any platform really. It's just the problem is that the way Angular projects are set, I think they only really run in Angular, but I'm not really sure about that, so I can't really say too much about it. As we all know, well, TypeScript, it gets compiled down to JavaScript, and SASS gets compiled down to CSS. And again, those are standards across all web browsers. The bigger problem about this project is that for the anti-cheat to work, which is not actually a proper anti-cheat, but again, it's for learning purposes, RapidMiner needs to be used. And RapidMiner is resource intensive in terms of the CPU. If you want to have fast processing speeds for, you know, supervised learning and unsupervised learning, so like predicting class labels or detecting outliers, uh, and the other machine learning algorithms. in terms of RapidMiner, it needs to run and it uses the CPU to do all those tasks, decision trees, and all that stuff. You're going to need a decent computer if you want the process of detecting the cheaters to be quick. That's why I wrote above that it should take up to maximum 30 minutes for the anti-cheat to perform, like for all the anti-cheat stuff to perform. So like extracting the tables from MySQL, importing tables into RapidMiner, and then running the model with the data to predict if somebody's cheating, and then running the SQL scripts to ban the cheaters based on the IDs of who's cheating. So yeah, requires decent number of resources, hardware, RAM, CPU. Will be slow if CPU processor is weak. So this is where, design constraints is important because it lets like what kind of resources the users or the server need. So if you were actually creating an anti-cheat, a real anti-cheat, which would be running on the client side, then the client, depending on what you're doing with the anti-cheat, the client might need, a decent computer or whatever. Windows batch scripts, I don't really think the only issue with Windows batch scripts is because since I'm running, this is where I stopped, and this is where I'm supposed to pick up. Basically, Windows batch scripts I'm pretty sure it's exclusive to Windows. I don't know if the language can be read across different operating systems if they're able to convert it to their own language. There's probably some like software or something that is able to do that, but to a certain extent usually. So that means that the anti-cheat is going to be exclusive. Anti-cheat of this project is going to be exclusive to Windows. So now we found a constraint in our design is that because we're using Windows Batch, which we could use something else, we could use a program or something, I guess, to automate these processes. But because we're using Windows Batch scripts, I'm assuming, constraint to Windows OS for anti-cheat portion of this project. Also, I want to preface, I don't know if I said this before, but I'm just fresh out of college. I just got my degree, computer science, so like I'm not an expert in anything. Still learning. That's the whole point of this. Quality attributes. I don't know. I don't really know what is meant by quality attributes under specific requirements. I guess it's the good things about the requirements that we have. I guess for us it would be Java, portable across many systems, I guess you could say. What else? I mean, it's popular language. So, I mean, I guess it's easy for people to, um, you know, if they wanted to edit. But again, I'm not sharing anything, so because I can't. But It's not because I'm greedy or something. I can't. This has to be for learning purposes. Otherwise, I would. But um, popular language. If anybody wanted to actually change anything that I did, then they could easily do it. If more people could do it because it's a popular language, so a lot of people know it. Windows, popular operating system, popular operating system. What else? I mean, it's pretty much all the same thing. Like RapidMiner, I guess, is popular and this and that. I guess we could skip that for now. I want to get this done quickly, and this just isn't that big a deal, I guess. I mean, I guess we should just complete it anyways. So Windows, popular operating system, RapidMiner, popular tool for Chris DM. So if anybody's into machine learning, stuff like that, and it's popular from what I heard. So people will be familiar with this tool if they know about machine learning. MySQL, I mean, it's just like any other database management system. It's popular. Popular. Popular database DBMS. We should do up here introduction. Wait. If I go down. Sorry. Send data acronyms. Introduction. Definition. DBMS. Database management system. Chris DM. Cross industry standard for data mining. Cross industry standard process for data mining. CR. Cross reference industry. I don't know. I guess. What was I saying? Yeah, actually, yeah. What I was saying was, I guess CR. This is for CR cross. So yeah, I just wanted to update that. I'm gonna have to end the video soon, not because I know we haven't. Maybe not. Maybe not. Maybe I can just do a little bit more before. Yeah, I think I'm gonna have to end the video here because my computer doesn't have much space left, and I have a bunch of videos I haven't uploaded in a while, and they take a lot of space, so I need to upload all of them and then delete them. Thanks for watching, and I'll see you guys in the next video. This was a short video, I know. And I think we're going to finish the software requirement specification document here in the next video. So thanks for watching.